All right, hello everybody. Today we're going to have another discussion of Ptolemy and his epicycles, and we're going to see how these epicycles actually connect to modern climate science and how Ptolemy's epicycles help solve climate science and climate change. It should be another fun discussion. I know that my discussions are maybe a little bit dry and I just do a lot of reading and talking and there's not much graphics, but I mean, you have to appreciate the content that I'm trying to bring to you here, right? So hopefully you don't mind all the reading and all the education and all the discussion of physics. So let's first read this document here called Copernicus Meets the Greenhouse Effect. Now, this is something that I wrote actually back in September of 2011. My, is that ever a long time ago now? I've been doing this for a long time, and I wrote this document originally for the group of scientists that I was working with. And I think we had a little bit of exposure on some websites. People were paying more attention to us back then. The group that, we called ourselves the Slayers. And so I wrote it for them and I wrote it for other people to read. And this did make some grounds, but nobody on the alarmist side obviously wanted to touch it and never wanted to address it directly because it fatally undermines them, of course. So this is titled Copernicus Meets the Greenhouse Effect. Let's read along with me, okay? Copernicus meets the greenhouse effect, the Earth-centered solar system. Ptolemy's epicyclic nested spheres model of the solar system, we remember we discussed this in my last video, worked wonderfully for predicting the movements and positions of the planets. It was a model which, for the time period, could correctly predict the broad observables, but it accomplished this with, as we now know, completely unrealistic internal physics and boundary conditions. So of course it wasn't absolutely perfect, as we know, as I discussed in my last video. There were errors and it didn't predict perfectly, and it had some fundamental problems which were well known for a very long time actually. Anyway, I just left it at that because it still worked well enough. It worked well enough for the precision of your eyes, but it did not work even then it still had a little bit of problems. Anyway, let's not get into those details. We discussed that enough last time. So what do I mean by broad observables? We refer to the actually observable. We refer to the observable and measurable characteristics of the system. So empirical observables, empirical observations. In the case of Ptolemy's model of the solar system, these observables were simply the positions and movements of the planets on the sky. And in Ptolemy's day, they probably didn't even have any idea that those were planets. Those were just simply points of light in the sky that moved. So Ptolemy and those people back then, around 0 AD, they wouldn't have even have known that those were other bodies. To them, it was just, well, there's a point of light in the sky that moves. So of course they're just coming up with what seems like a rational model to explain it. Well, it probably must move in a circle, so that's why they use perfect circles, right? So you can totally understand why they did what they did. So the observables were the positions and movements of the planets on the sky. The meaning of this term is self-explanatory. So broad observables. How one interprets the meaning of the term boundary conditions is a somewhat more philosophically and interestingly scientific concept. The idea of a boundary condition can be understood to apply to the physical conditions of a system, and we have that in quantum mechanics, for example, boundary conditions which govern the behavior of a system, but also to this is really important, to the cognitive domain, which is created and then bounded by the assumptions which go into establish what are believed to be the aforementioned physical conditions of the system. However, the assumed physical conditions of the system, the ones that you've assumed, which establish what type of mathematics and physics are then created by the human mind in the attempt to characterize the system under those conditions and understand its observables, may be incorrect, even though you might still succeed in creating a physics and mathematics which satisfies the observables. So in this case, the internal physics would not correspond to reality at all, perhaps, even if the math and physics might make a few successful predictions of the empirical observables. So the Ptolemaic solar system is the pertinent example. For 1400 years, we assume that the Earth is at the center of the solar system because this seemed to be a perfectly reasonable assumption, given that we observe the sun, stars, and planets circling about us every day and throughout the years. But there are slight variations in the observed tracks of the sun and planets relative to the fixed firmament, the background stars, and so a physics of epicycles was created to explain and describe those variations. As we've saw in the last video, that diagram that showed the circles with the little circles moving on top of it, and we'll come back to that in a little bit. Given the time period and its associated knowledge and technology, this model of the heavens was believed by the vast majority of natural philosophers, scientists and philosophers, what passed for scientists back then, and certainly the philosophers, to explain the universe well enough indeed, right? And that lasted for 1400 years, okay? So in this model, we had a cognitive boundary condition, the implicit assumption that the Earth was at the center of the heavens and that the heavens circle about it. So that created a cognitive boundary condition, a boundary condition in our mind, and a set of axioms in our mind from which then we would begin extrapolating physics to explain how the system must behave or would have to behave in order to explain the observables, the empirical observables, under those assumptions, under the conditions of those assumptions. So looking back with the advantage of our knowledge today, we understand that the Ptolemaic model was actually only a cognitive boundary condition, not corresponding with the actual physical ones, corresponding with reality. We assumed an Earth-centered universe with the planets moving in perfect circles about it, and then we created physics to satisfy that. So with the assumption of an Earth-centered universe comes a defined cognitive domain, or a mental phase space, or a mental boundary condition, a set of axioms into which research and thought on the nature of the universe is then conducted within that paradigm. That's called the paradigm. Once a paradigm becomes firmly entrenched, it can take thousands of years before someone thinks of questioning the primary assumptions of that paradigm and of the assumptions and axioms of that paradigm, the foundation of that paradigm, in the face of unexplained observables or errors in the empirical measurements relative to the model in theory, as had been the case for the Ptolemaic model. And of course, the difficulty becomes insurmountable in consideration of, when you have massive systems of authority and control and money involved in, that are supporting and at the basis of the system, right? Look at Giordano Bruno, for example, was burned at the stake for saying that perhaps the heavens is different than we think of it. And Galileo was put under house arrest, and he was nearly put to death as well. So Copernicus and the greenhouse effect. Fast forward to 1543 and the publication of On the Revolutions of the Celestial Spheres by Nicholas Copernicus. The Copernican revolution wasn't merely just a change in the assumed physical conditions of the system. It represented an entirely new mental phase space, an entirely unique mental boundary condition in which the human mind could explore permutations of a new set of axioms, of a new axiomatic field, and extrapolate totally new physics. It was a total qualitative change, not just a quantitative shift. It wasn't just a slight improvement to the measure, to how we predict things and to get better agreement with the empirical observables. It was a total qualitative shift in cognition, where essentially none of the previous physics or mathematics had any longer any relevance or meaning. The observed facts or broad observables remained entirely the same, the position of the planets on the sky. But now the new underlying assumptions directed an entirely new and unique physics and unique math. And of course, as I discussed in my previous video, it was actually Kepler who did a lot of that, although people simply recognize for historical reasons that it was Copernicus, but Kepler really had a large part in actually determining the new physics of this system. Because it was Kepler who actually said that the sun was a governing body that must govern with a force similar to magnetism. That was what Kepler said. Of course, that turned out to be gravity, as Newton later developed. So the Copernican paradigm created an entirely new cognitive phase space which minds could explore, leading directly to brand new thoughts and physics of those such as Kepler and Newton, and all the way to Einstein and modern physics. It is very easy to conclude that the success of the Copernican model in the history of science, that is the sun-centered solar system, is due to the logically valid fusion of both your cognitive boundary conditions, how you're thinking of the system, and the physical boundary conditions of the system, how the system actually physically does behave, right? The way you're thinking about the system mentally, your mental boundary conditions, the mental axioms by which you are thinking about it and extrapolating and developing mathematics for the system, now actually match to the actual way that the system physically does actually exist. So the way we started thinking about the system is the way that the system actually does exist. Okay, there's a correspondence between your mental phase space and your physical empirical phase space. And therefore, the model really worked, and we still use that physics that Kepler developed for that to launch rockets into space, and it works quite well. because it's ontological. The sun really is at the center of the solar system, and planets really do circle about it because the sun really is a governing body. So this is a previous paper that I had written. Perhaps I'll link that one as well. So in a July 2011 paper, I reviewed the standard model. This is referring to the climate model, the standard climate model, which we're all familiar with, the flat Earth model, and associated boundary conditions of the radiative atmospheric greenhouse effect, which is postulated to explain the near surface air temperature on the Earth. The paper cited 63 major references to the model of the greenhouse effect, which I've shown you. I usually show that one graphic which shows 6 because they're nice graphical representations of that flat Earth model, which they have for the climate. Which included academic sources such as Harvard's Atmospheric Chemistry Modeling Group, Pennsylvania State University, the University of Washington's Department of Atmospheric Sciences, a multitude of others, NASA, government websites, etc., etc. I clearly recall my own undergraduate astrophysics training at the University of Western Ontario, where in the first year, it was actually in the second year, maybe it was in the first year, but now I'm remembering it as my second year. In physics, we were taught this very same model as well. I remember it now. Clearly, the model discussed in the July paper is the standard model of the postulated greenhouse effect in Earth's atmosphere. It is reproduced below. So here it is. I just drew it myself. You guys have seen this many times in other guises from official references such as Harvard and whatnot. So the standard model of the greenhouse effect, this model contains the boundary conditions. That is the mental boundary conditions, the way we think about it, and basic physics which characterize the system under the atmospheric greenhouse, the greenhouse effect of climate alarmism. Readers can examine the full mathematical breakdown of this model in the July paper. Here, let us simply examine it in terms of the concepts we've introduced here, the observables, the boundary conditions, the paradigm, and the internal physics. The observable is a little bit more technical than its analog in the solar system models. The observable here is related to the law of conservation of energy, i.e. that the energy coming in from the sun must equal the energy being output from the Earth. So that's the input here, and that's the output here. As you know, what has been done is they have equated the output of the Earth to the input of the sun. And they have done that because they think that that conserves energy, that is a statement of the law of conservation of energy. So the energy coming in from the sun must equal the energy being output from the Earth. So this observable is captured, the way they do this, under the label of incoming solar flux and its related mathematical expression. So the output flux of the Earth is 240 watts per meter squared. So this term is balanced by the outgoing terrestrial radiation, which has the same numerical value. So the outgoing terrestrial radiation is this value, and then they say that that has to be the same as what the solar input is in order to conserve energy. These two observables represent the boundary conditions of the model. So that condition represents the boundary condition of the model, the mental boundary condition of the model, from which then other physics and mathematics is extrapolated under that mental boundary condition, under that axiom. So physically and cognitively. So you have a physical model here, and then that's how you cognitively think about it. The internal physics is then everything else that happens within the guise, like the physics and math that you develop then for that model, happens within the guise of that boundary condition. So the boundary condition is this incoming solar flux being equal to the flux output of the Earth. And of course, it's also drawn on a flat plane and flat line here because they're averaging it out. So let us more closely examine the boundary condition and associated paradigm of this model. It uses two horizontal lines, one to represent the ground and one to represent the atmosphere. This is called a plane parallel model. The incoming solar flux is divided by a factor of 4, and this is the numeral 4 that we always see in all those diagrams right there, just as we've seen in those other diagrams. So as to average the solar energy over the entire globe, because the globe is actually a sphere, but we draw it as a horizontal line or plane for convenience. But at the expense of a larger diagram, we can just as easily use the same averaged values and draw the model as a circle, because that would more intuitively represent the Earth as shown in figure 2. So why not just extend that plane from the previous diagram into a circle so that it represents the Earth, and then we have a circle where the incoming solar flux, or we have a sphere where the incoming energy is coming into the planet from all directions all at once, and there's no day and night, and then you equate that energy to the output of the Earth, or you have the output of the Earth, and then you equate that, or you say that that's what the sun has to be equal to in order to conserve energy. So the output of the spherical Earth has to be the same as the input to the Earth from the sun, and then you have to treat the input from the sun as coming in all over the entire surface of the Earth at once. So A neo-Copernican paradigm shift. In the above figure, it is much simpler to observe that this standard model greenhouse effect treats the solar insolation as coming into all sides of the Earth at once, and it justifies this boundary condition by using what is said to be the average value of solar power. All well and good. However, does the light from the sun actually come into all sides of the Earth at once? Obviously, sunlight actually only comes into one side or hemisphere of the Earth at any given time ever. This is assumed to not be a problem in the standard greenhouse effect model because we're using the average value of the intensity of sunlight anyway, and so it is considered to all work out as equal in the end. But are we sure about that? In this standard model, what are the physical units used in quantifying the solar power? This was cited and it's listed as this flux value, 240 watts per meter squared. A watt is a joule per second, so the explicit units of this is joules per second per square meter. And it's an amount of energy spread over 1 second of time spread over 1 square meter of space. Such a quantification of energy is known as energy flux density, which is sometimes called power, but power is actually only joules per second. Flux is joules per second per square meter, which gives it a density, a spatial density, and a temporal density. So it's a density in time and space. What this value of solar power represents is therefore a 1 second average snapshot of radiation coming into and going out from the Earth over its entire surface area according to the standard model, right? So it's per second and per square meter. So it's supposed to represent as a flux, a snapshot of what happens in any particular given second. So are we sure that this adequately describes the real physical system? The standard model effectively treats the Earth as having sunlight coming in over all parts of the Earth at once, with no daytime and no nighttime, and with 1/4 the value of the incoming energy flux density of the actual solar power to account for this, right? That's that division by 4, which makes it equal to the average terrestrial output power. This boundary condition is justified in that model because it's claimed to satisfy the broad requirement of conservation of total energy, i.e. that the solar input must equal the energy of the terrestrial output. However, there is a physical error in this. The model equates the energy flux density of the incoming power to that of the outgoing power. And this is not actually part or a requirement of the law of conservation of energy. The law of conservation of energy pertains to total energy, i.e. the total number of joules, and that should be in a given second, but not to the flux density of those joules. So this is a fundamental error in the primary boundary condition of the model, and it sets up a cognitive phase space, which therefore may not necessarily correspond with reality. So the error is twofold. One, in treating the Earth as if it has no daytime and nighttime, which is, of course, their flat Earth theory. And two, in equating the energy flux densities for the law of conservation of energy, as opposed to the specific total energy per second. So the reason this is an error is the Stefan Boltzmann law of radiation, which can be used to convert radiative energy flux density into an equivalent temperature. So the model average solar input power, which divides the real solar power by 4, to make it equal to the terrestrial flux, that is 240 joules per second per meter squared. So that's 240 watts per meter squared. Energy flux density has an equivalent temperature. So the temperature of that energy would be minus 18 degrees Celsius. So that's the output of the Earth. And that's equated as being equal to the solar input, or what the solar input must then have to be. With the cognitive boundary condition that the sunlight only provides minus 18 C worth of temperature in any given second over the entire surface area of the globe at once, you then must postulate a scheme of physics to raise the temperature on the Earth to something much warmer than this. This scheme of physics is called the greenhouse effect in climate science, and of course it's not how an actual real greenhouse functions. It's something alternative. It's a radiative greenhouse effect, and it only exists in climate science. The average daily temperature found near the ground surface is plus 15 degrees Celsius, so it seems apparent that solar sunlight cannot directly account for anything above minus 18 degrees Celsius, since minus 18 degrees Celsius is the output of the Earth, and this, in their model, has been equated to the solar input, because they're equating flux. So in a physically realistic 1 second snapshot of the input and output energies, however, not flux, but energies, solar power, not solar flux, but solar power actually only comes into one side of the Earth in any given second, and ever. This means that there is no possible way that the energy flux density of input versus output could be the same in numerical value, right? Because flux is averaged over the space that the energy occurs on, right? So does the energy from the sun occur over the spatial area of the entire surface area of the Earth? No, it doesn't. The input from the sun only ever occurs on the hemisphere, on the daylit hemisphere, whereas the output from the Earth obviously comes over the entire Earth, the entire sphere's area. So, but the output comes from the surface area of the entire sphere. And since a hemisphere is half of the surface area of an entire sphere, the average input energy flux density must have a value twice as large as that as the input. The total energy balance between input and output is still exactly the same, satisfying and in line with the meaning of the law of conservation of energy, but the energy flux density or power temperature of the radiation is not and never needed to be the same in numerical value. So what would Copernicus think of this? The standard model greenhouse effect makes a simple but critical mistake in not differentiating between the concepts of energy flux density and total energy in the context of the law of conservation of energy. Along with this comes the unrealistic model of a dim, cool sun simultaneously shining on all sides of the Earth at once as an input. This establishes a cognitive condition or a paradigm which does not conform to reality. So we have a cognitive paradigm, a cognitive space, a way that we're thinking about the system which does not actually correspond with the actual physical conditions of the system. So what's going to be the result of that? In reality, an actual per second per square meter snapshot has the sunlight falling upon one side of the Earth at any moment in any given second, and the Earth returning energy to space over both the light and dark sides of the Earth. This was discussed and mathematically proven. Of course, you have to mathematically prove that the sun only receives, or that the Earth only receives light on one hemisphere. I mean, you have to mathematically prove this for scientists today. A model which incorporates the physical boundary conditions as they really exist was presented in that paper and is reproduced, shown in Figure 3. So look at how long ago I produced this model, actually. So here, of course, we have the sunlight coming into one side of the Earth at once only. The Earth is rotating beneath that. The solar input flux is actually very high. The flux from the sun is actually 1,370 watts per meter squared. But the flux from the Earth is actually only, well, this works out to 240 watts per meter squared. So you see that there's actually a difference in the flux. So there's a difference in the energy flux density. So the input energy flux density from the sun is 1,370. And I didn't write it in here, but we saw it before. This is 240. So the output energy flux density, or the output flux from the Earth, is 240. So you see that the fluxes are not actually equal. What is equal is the total energy, right? Because if you multiply this flux over the surface area that it occurs on, that then is actually equal to the total energy of this flux multiplied over the surface area. So you do have conservation of energy, but the fluxes are not the same. So what they've done in the greenhouse effect model of climate science is to equate fluxes and say that fluxes must be equal to conserve energy, but that's not true. It's total energy that needs to be equal in order to conserve energy, not the fluxes. So the input flux from the sun is quite warm. This works out to plus 121 degrees Celsius, and that's, as we have said, more than hot enough to evaporate water, generate the climate cycle, etc., to create our climate, to sustain our climate. And their scheme, where they equate fluxes, the solar input is only this minus 18 degrees Celsius. They've reversed this output of the Earth as the input of the sun because they think those should be equal values. Of course, they're not. Solar input is not minus 18 degrees Celsius. If solar input was minus 18 degrees Celsius, then you have to come up with another scheme for how the climate is created. Okay? And so, in fact, the temperature forcing into the climate system from the solar energy has a linearly distributed average value of plus 30 degrees Celsius. So that would be the average value on the daylight hemisphere is being heated to plus 30 C on average, although it's really an in situ because the equator actually receives much higher energy than this, and all sorts of physics is created at the equator, and then that heat flows to the poles. In any case, at maximum intensity directly under the solar noon, this input forcing is potentially as high as plus 121 Celsius, but the daytime hemisphere of the Earth doesn't actually achieve even plus 30, even though we know that it absorbs all the energy required to potentially reach this temperature. So where does the extra energy go? It's very simple. It goes into other degrees of freedom in the system, which is our climate. That's the climate. That's heat flow through our climate, which is latent heat, evaporation, convection, the Hadley cells, the heat flow from the equator to the poles, rain, snow, wind, etc. And it goes into also warming up the ground from the surface temperature, because obviously the ground cools down at night and then it warms up again from solar heating in the daytime. So this new model directly achieves the law of conservation of energy, but it does with correct internal physics. So the boundary conditions of this model, the way we're going to think about the Earth and solar input and climate in this model, corresponds to the actual physical conditions. So our cognitive domain, our cognitive boundary conditions, how we're going to think about the system actually corresponds with the way that this system actually physically exists in reality. So now you have a fusion between how you're thinking about the system and how the system actually empirically exists, and so you're going to now have a much more fruitful physics developed, aren't you? Copernicus's bachelorhood and frozen dinners. Does it really make that much of a difference to use the actual value of the energy input versus simply equating that parameter to the output density of energy? Yes, it does. Imagine that you start the Earth system off in some model from absolute zero temperature, completely frozen, and then begin inputting energy as per the standard climate science model. Minus 18C worth of temperature forcing coming into all sides of the planet from an omnipresent and an impossibly omnipresent dim and cool sun. So some sort of sun that's spread all over the whole entire sky and giving minus 18C input. So would you expect a minus 18C worth of temperature forcing from sunlight to be able to melt the ice and frozen oceans that are the Earth? Because we're starting the Earth off at zero Kelvin. Of course, you would not expect that. Minus 18C is not going to melt the ice. On the other hand, what if you had plus 30C worth of temperature forcing on half of the Earth, and the Earth is rotating through that half every day, every 24 hours, with a maximum underneath that half, underneath that hemisphere of plus 121 Celsius? Well then, yes, you would expect that ice will be melted during the day, and it's going to be melted pretty good, and who knows, you'd have to run that system. Obviously, we have the real world example. Our Earth is warm, and there's clouds and water and rain and all sorts of stuff. So obviously, indeed, we should certainly expect that this actual flux, temperature, input power level of solar energy to melt the ice into water and to cause evaporation and generate the climate cycle, as we know that that actually exists, because the solar input is not actually minus 18C, as they have depicted at the very basis of climate theory. This is the beginning of climate science, and certainly climate alarmism. So most human beings are familiar, I did a video on this previously, with cooking their own food, and so there's a very simple analogy to understand how this thermophysics works. Take, for example, a frozen TV dinner. Typically, you have to cook these at 425 Fahrenheit for 60 minutes. It's been a while since I did that, maybe it's 30 minutes. Could you substitute for 1/4 of the power, but cook it for 4 times longer and expect to achieve the same result? Could you, on the other hand, substitute for 4 times the power and cook it for 1/4 of the time period? Could you imagine attempting either of those scenarios with a 25-pound turkey? So cook a turkey at 30 degrees Celsius for a day. What's going to happen to it? Nothing. Okay, well then cook it at 1,000 degrees Celsius for 15 minutes. What's going to happen then? You're just going to set it on fire, right? The flux, and that's a function of the flux of the actual input energy. You could average those and say, well, the average of 1,000 degrees Celsius input over 24 hours is actually only really cold. And it's like, yes, but when that 1,000 degrees Celsius input for 15 minutes is occurring, you're going to incinerate that turkey, right? So it matters when and where the power actually takes place, which is your flux, which is why we need to think of the sunlight input that way as it actually occurs, not this average minus 18C value, which is actually only the output of the Earth. That doesn't make any sense to say that that's what the solar input is, because obviously the solar input is much hotter. So could you imagine it? Yes, okay. So the total energy spent, yeah, so the thing about that is that the total energy spent would be the same in those scenarios, but the physical response in each is entirely unique because the flux is different. The total energy is the same, but the flux of that energy is very different. And the flux of that energy is what determines what physics actually occurs. So there are valuable, actual, and real-world differences between the standard model greenhouse paradigm and the paradigm I explained above, the physically correct model I explained above. So just as there are such differences between the solar system models of Ptolemy and Copernicus, there are also such differences between the standard greenhouse effect model and the reality model reviewed here and presented in the July paper. This new model has boundary conditions which are both cognitive and physical in a logically valid fusion, so they correspond to each other, just like the Copernican model or the Keplerian model, as opposed to the Ptolemaic. We have adherence to the exact same empirical observables, but completely different internal physics and a completely different paradigm and thought process which describes it. The atmospheric greenhouse effect is really just an artifact of a fictional boundary condition and its associated aberrant or incorrect cognitive domain. So here we have Ptolemy's epicycles solve climate change. So remember this diagram. So here's Ptolemy's model, an Earth-centered universe, solar system with the planets moving in perfect circles about the Earth. So how does that correspond to this diagram here, which is the standard climate science, the basis of climate theory, the basis of the way that all of climate science approaches the understanding of the climate? They've even said, you're only criticizing the basic model that we use to understand the system. And it's like, yes, I know that's what I'm criticizing, and I'm criticizing it because it's incorrect. All right, so what can we say about this? So just as Ptolemy's epicycles were an artifact necessitated out of faulty initial assumptions, so they were invented simply for the purpose of making the model work. So Ptolemy invented these epicycles, where the planets move on tiny little circles superimposed on top of the big circle that they travel around the sky in, right? So Ptolemy invented these epicycles in order to make the model work. So in order to make this model, this idea work, where the Earth is at the center of the universe and the planets move in perfect circles around it, he had to introduce these epicycles in order to force the model to work, in order to make it work. So just as Ptolemy did that, the greenhouse effect of climate science is likewise an artifact created out of the mathematical extrapolation of the faulty initial conditions of what? Flat Earth theory, and the sun not being able to create the climate or heat anything above minus 18 degrees Celsius. So those are connected. It's Flat Earth theory, and the consequence of Flat Earth theory is that the sun cannot heat anything above minus 18 degrees Celsius. So because they start with that idea, in order to force that model to work, they then come up with a heat recycling, reverse heat flow from cold to hot, essentially loop here, which is basically an epicycle, a little circle, a little loop happening on a big loop. So here we have Flat Earth theory with cold sun. In order to make that theory work, they come up with this idea of an atmospheric greenhouse effect, where the energy from the atmosphere loops around, cycles around here, amplifying its own temperature with reverse heat flow. Because they cannot explain why the surface is so warm with only a minus 18 degrees C solar input. So with only a minus 18 degrees Celsius solar input, they then say, in order to make that model work, when we know that the surface temperature is much hotter, let's create an epicycle, or a loop of energy flow from the atmosphere back to the surface, where the energy from the atmosphere warms up the surface some more. Even though the atmosphere is colder than the surface, somehow it sends energy back in a temperature increasing function, which would then mean that it has to be heat, which then means that it has to be heat flow from cold to hot. Okay, so that's what they've done. They've created an epicycle, an artificial set of physics, in order to satisfy the assumption of their cognitive domain of their boundary conditions, where the solar input is only minus 18 degrees Celsius and unable to create the climate. Okay, so never forget that real greenhouses actually empirically disprove the temperature amplification mechanism proposed by the alternate climate science greenhouse effect and the first law of thermodynamics. So this loop, this epicycle they've created in here, this backwards arrow, which is basically an epicycle of reverse heat flow, first of all, that's not consistent with the first law of thermodynamics. Secondly, even though this does not represent the actual Earth in any way whatsoever, you could say, let's improve this model, let's get rid of this dividing the solar power by 4, let's use the actual real-time solar input and use this model for a greenhouse building, for an actual real greenhouse. This can be the roof of the greenhouse, this can be the floor of the greenhouse, and we'll have walls in the greenhouse. Now let's see if this loop actually exists in a real greenhouse and produces the temperatures that you would then expect under this physics. And you know what happens? You do not measure in real greenhouses the temperature amplification that would have to occur if this greenhouse, radiative greenhouse, climate science greenhouse epicycle actually existed. The only thing you measure in real greenhouses is the temperature produced from the actual real solar input, not the divided by 4 solar input, because why would you divide what's real by 4 in your model? You use the real solar input and you find that a greenhouse only comes to the temperature of the solar input. If this radiative climate science greenhouse effect loop was actually a real physical thing that existed in physics, that existed in reality, then you should be able to empirically measure its consequences, which would be an amplified temperature relative to solar input. It should become much hotter than the solar input in real greenhouses, but you do not measure that. So that means that you do not measure it because it doesn't exist. So it's an empirical refutation. And we already have the theory of why you're not measuring it. Well, you're not measuring this epicycle because this epicycle doesn't exist, because it does not correspond with the first law of thermodynamics and the equations for heat flow and whatnot. So we already have all the evidence and all the theory required to refute it, but they are incredibly wedded to this model with its epicycle, just as for 1400 years people were wedded to the Ptolemaic model. So a Copernican revolution for climate science. What is that? Put the sun at the center of the climate. Isn't that a wonderful idea? A Copernican revolution for climate science put the sun at the center of the climate. The beginning of climate science, so the way that our climate scientists, the way that climate science begins its understanding of the climate is to say that the sun has nothing to do with it, because they have the sun at minus 18 degrees Celsius, which is effectively saying that the sun has nothing to do with the climate. That's just like Ptolemy saying that the sun had nothing to do. Of course, you can justify them. In the modern day and age, you cannot justify what these people are saying today. It was reasonable for Ptolemy to make the assumptions he did because they had no idea what they were looking at. They were simply looking at what appeared to be lights moving around in the sky. They had no idea what they were. In this case, however, they're beginning climate science, modern climate theory, and this is in physics textbooks and physics publications. They have removed the sun from the center of the climate by treating the sun in these flat Earth diagrams as only minus 18 degrees Celsius. So in order to justify a flat Earth approximation to the entire Earth, they've made the sun minus 18 degrees Celsius, effectively removing the sun from the center of our climate. Just as Ptolemy did not have the sun at the center of our solar system as any sort of important force. Obviously today, we know that the sun is a governing body of the solar system and governs the movement of the planets through gravity, right? In the future, we will know that the sun is at the center of the solar system and governs the behavior of our climate as a physical force by heating the heck out of the equator, and that heat flows to the poles and generates the climate in that process of heat flow. So what are their conditions? What are the conditions that climate science, modern climate science, and modern physics starts with? The sun does not heat the earth or sustain the climate or the weather. The atmosphere somehow produces twice the heating power of the sun, even though the atmosphere releases no new energy. Heat flows from cold to hot, which is obviously impossible. Output reversed for input. It's flat Earth theory as modern physics, and it's disproved by real greenhouses and totally failed climate predictions in general. In general, the climate predictions have totally failed. The warming that they predicted has never manifested, etc., etc., etc. So if we put the sun at the center of the climate, then what do we have? We have that the sun heats the earth and it creates and sustains the climate and the weather. How wonderful would that be to have a climate model and the basis of our climate physics and understanding based on that? Heat flows down gradients from warm to cool, and that process is the climate. There's no new or exceptional thermodynamics required, and it is a spherical Earth for modern physics. Wouldn't that be lovely? Isn't it lovely, guys, being able to have such clear, rational thoughts and thinking, especially if we go back to this example? Isn't it wonderful, if you're following along with me, to be able to compare this diagram and see that there's an epicycle occurring here which has nothing to do with reality but was invented to fit the model? And over here we have an epicycle of reverse heat flow which has nothing to do with reality but was created to fit the model, to make the model work. Isn't it great being able to have such clear, rational thinking? Isn't it wonderful? Now imagine the mind of our scientists. Now imagine the mind of a PhD in physics who you can present this to, and they have no idea what this means. They have no idea what they're looking at. They have no idea of the meaning. Now, for example, for you, watching this video, I know most of you are on board with me here and can understand this. You see the relevance here. You see that this has meaning. You see that it has consequence. You see that it's actionable, right? And how is it actionable? It's actionable by you can create a much better model, as I've done here. You see that there is real-world relevance here. You see that there's a choice that you can make here. You see that there is something effectual here, which you can change your thinking with, which you can improve your thinking with, which you can go on with an understanding that you now have a much better understanding of how reality works, and it's satisfying for you, right? Because you have a mind like mine, a rational, clearly thinking mind. Now imagine our modern PhDs in physics and climate theory who cannot comprehend this, who cannot comprehend the difference between saying that the sun does not heat the earth and that the sun does heat the earth and creates the weather. Imagine how dark of mind you must have. It really makes you wonder, what kind of force are we dealing with? I have spent many years wondering if these people are robots, or if they're an enemy. I said in my last book that perhaps we're facing an enemy, or perhaps they're robots. These people are robots, these donkeys I talked about in my last video. Perhaps they're robots programmed by an enemy. Because the result of this is the vilification of carbon dioxide, which is the molecule that is at the basis of life. Carbon dioxide is the life molecule. Carbon dioxide is how carbon gets into the biosphere as an organic agent to create DNA and all life. That's how life is created, through carbon dioxide in the atmosphere, along with, obviously, water and sunlight. Okay, it's carbon dioxide in the atmosphere. They have created, out of this insane Ptolemaic epicyclic flat Earth model of climate, where the sun is nowhere near the center of the climate, what has come out of this is an absolute fear and hysteria over the life molecule, over carbon dioxide, such that they want to get rid of it. They hate carbon dioxide and they want to get rid of it. What is the result of that going to be? What if these people get into the power positions that they can institute some crazy, insane geoengineering system where they think that they should remove all the carbon dioxide from the atmosphere because the carbon dioxide is creating the climate? What's going to be the result of that? Of hating the molecule that creates life. And there's no evidence that it creates any warming whatsoever. And there's not even any evidence anymore that humans are causing it. If you look at, I'll maybe discuss this in a future video, if you look at the CO2 concentration curve, a year after lockdown, a year after massive economic shutdown, the rising CO2 curve has not changed one bit, which means human activity is not causing the increase in CO2. It's entirely natural anyway. In any case, imagine the minds that we're facing. Imagine that our PhDs in physics are unable to understand, are unable to engage in the clarity of thought that you're thinking. You know, we're looking at potentially a total breakdown of the system, a total rejection, a total loss of all truth in the world. The truth is going to be gone from this world, and we're going to live in a world of complete sophistry. It is at least going to lead to some sort of collapse or revolution or something. And why shouldn't it? Because look at our education system. If our education system, starting from kindergarten, ending with PhDs in physics, so people who spend 25 years in school basically, or 20 years in school, 8 years getting a PhD at the highest level, and what results from that? What results at our highest levels of education, our highest possible cream of the crop, the people who are celebrated as being the most brilliant exemplars of humanity. From our whole education system, you start off from a child in kindergarten, you end some of us with PhDs in physics. And what happens? Those people cannot understand the difference, cannot understand what I am talking about here whatsoever. They cannot understand that flat Earth theory is wrong and should not be used. They cannot understand the difference between sunshine being hot and sunshine being cold. And of course, they've been educated into this, haven't they? because they're quite comfortable with using mathematics where they don't know what the hell the mathematics actually means and what it stands for whatsoever, as long as they get some useful results from it. And, you know, they believe that they're getting useful results from this. You're not getting useful results in the first place. Your results from this are that the sun doesn't create the climate, that solar input is minus 18 degrees Celsius, and it's a flat earth model. Yet they've been so indoctrinated via quantum mechanics into using mathematics where they have no idea of what the mathematics actually means underlying at all. They have no idea what quantum mechanics means. They have no idea what the mathematics of quantum mechanics means. And so, but yet they go on and just shut up and calculate, and they don't care. So they've been conditioned into not caring whether or not the mathematics means anything, because they don't care if the mathematics means anything or corresponds with reality whatsoever. So they use a model like this, and they say, well, this flat Earth model with an epicycle can predict the surface temperature if we jig it in such a way to make that work, and therefore it works, because that's basically what they do in quantum mechanics, right? Now, quantum mechanics actually has been licked, it has been solved, it has been ontologically figured out what the math actually means, and it's not probabilism and whatnot, and you can read the Mike Hockney books, the God series Mike Hockney books. Perhaps some of you have seen me reference them before, but anyway, if you want to look it up, if you want to look up how to understand the mathematics of quantum mechanics and see that it's actually deterministic, it's not probabilistic. It's only probabilistic in the sense of tossing a coin. A lot of people say that tossing a coin is an example of randomness. It's not actually random. It's only effectively random. It's effectively random because when you flip that coin, you know, you might not know where that coin started, and your mind and your eyeball processing isn't fast enough to watch that coin flip over and see where it lands. If you had computer vision scanning at 100 hertz or something like that, imaging at 100 hertz, then you could count exactly how many times it flipped, and you would know every single time exactly how that coin is going to land. So it's only a consequence of you not having the processing ability and not knowing the initial conditions. That's why we call a coin flip random. But a coin flip is not actually random. It's only effectively random due to the limitations of our understanding of the system. So it's similar to like that. It's similar to that for quantum mechanics, actually. And we can now actually lick quantum mechanics and understand it fully. So read the books. They're on Amazon under the author Mike Hockney, and the series is called the God series by Mike Hockney. So which one? Sun creates the climate, so a Copernican revolution with the sun at the center of the climate. Sun creates the climate. Climate is transfer of solar heat. That's what the climate is, the transfer of solar heat with the sun at the center of the climate. Input transfers through to output. You have physically real, mathematically realistic boundary conditions, both in your model and in the way you think, and those boundary conditions correspond to what actually physically exists, consistent with thermodynamic laws, empirically observable, but hilariously not acceptable to peer review science. So sun, sphere, Earth, very hot, solar flux, very cool, terrestrial Earth output. The sun is hot enough to create the climate, create clouds, cumulonimbus clouds, and generate the Hadley cells and create the heat flow from the equator to the poles, which is our climate. Okay, or the flat Earth model. Literal flat Earth, a literal line drawn as flat Earth, and our PhDs in physics are brain-dead donkeys. They look at it like a donkey would look at it. You could show this to a donkey, and what will a donkey say about it? Nothing. They'll bay at it because they have no idea what they're looking at, and they can't tell the difference between this and this. That's our PhDs in physics. Bring on the damned collapse. Bring it on. Bring on the absolute collapse, because we need to collapse all the way down to kindergarten, because this is what you get in our physicists with PhDs after 20 years of education. It's obviously worthless. We're going to need to experience a collapse all the way down to the kindergarten level and build back up from there. Sorry, but that's what's going to have to exist, okay? Because our physicists can comprehend the difference between the right side of the diagram and the left side. They can comprehend the difference here as well as a donkey can comprehend it, which is to say, not at all. Isn't that an amazing state of affairs? I mean, my goodness, people. My goodness. Okay, I think that's it. All right, hopefully, oh my, 50 minutes. All right, guys, hopefully you can get through all this. And again, as always, take care. Please spread these videos around. My goodness, people, we need to get this out. we're going to have to form some sort of a group called, I don't know, let's call ourselves the rational vanguard or something. I don't know. We're going to have to hold, the world is going to devolve into a completely sophistical, insane state, as it already has, where we have people in government and politics and politicians supported by PhDs in physics who believe in flat earth theory and are going to be developing political policy based on flat earth theory. It's going to be hell. It's going to be a complete and utter collapse. So let's please, those of us who understand me, we're going to have to form some sort of group, some sort of brotherhood, sisterhood group, whatever you want to call it, where we hold the truth and the light as the world goes to shit, right? Because the world is going to have to collapse back down to the level of kindergarten, and we're going to have to build back up from there, okay? We already have it. I know how to do it. I'm already developing a whole new education system because I'm homeschooling my daughter, so I'm like teaching mathematics in a completely different way. Actually, I've been following standard textbooks, but I can see what's going wrong with them. We should start kids off with learning the complex number plane. We should start with that. The very first time you introduce numbers and what numbers are to kids, you should right away introduce to them the complex number plane and what it is and why it's important. Not this, we'll start with positive real numbers only, because actually that's where physicists still are. Physicists are still in the domain of only positive real numbers are meaningful. And why are they still there? Because that's what you learn in kindergarten and grade 1. And that's why we need to devolve back to kindergarten and grade 1 and have a destruction of society to that level so that we can rebuild back from there. And when we rebuild, we're going to be there to start teaching numbers as the complex number plane. We're going to start with that. Start with the complex number plane. Physicists are still in kindergarten where they believe that only real positive numbers have any meaning in reality. Okay, anyway, that's getting into ontological mathematics. Please read the Mike Hockney books, the God series. You won't agree with all of it, but the vast majority of it is excellent. It's the highest expression of reason which has ever existed on our planet, and it solves all these insane problems that we're currently experiencing. Okay, everybody, have a good day. Please share the video. Please get this out. I mean, come on. Is there really no scientists who can understand this? Is there really no PhDs in the world? I've had success with no other mainstream PhDs anywhere on this. Like, can you believe it? Regular people understand this. PhDs have been so educated out of their intelligence. Educated beyond their intelligence is the expression, I think, right? Is there really no politicians? No one with money, no groups that would want to support this and fund this and get this out there and bring it to the people? Is it me and my few watchers on here? Are we really the only people that can understand that flat earth theory with cold sunshine is not a valid way to understand the climate, to begin understanding the climate? Are we the only ones? I mean, if we are, we really have to take care of each other, okay? And we're going to have to hold the truth and the light or something like that while the world goes absolutely insane. But hopefully we can get around that and get past that. There's a solution. I know there's a solution coming. I know we're going to win. It's always darkest before the dawn. I know I'm saying a lot of negative things here, but that's just to point out just how absurd it is. We're going to win because, in fact, we have the easiest possible enemy to defeat. Our enemy is thinking at kindergarten level. Our enemy is so incredibly stupid. They're basically donkeys. So it's really just a matter of figuring out how to herd the donkeys, right? We can win this easily. It's, in fact, the easiest thing to solve in the world that you've ever encountered, right? Because just showing people the difference between black and white, between a flat line and a spherical Earth, right? So actually we have this in the bag. It's just, I don't know, something seems to be holding it back a little bit for now. Okay, anyway, that's been another 5 minutes rambling. So have a good day, everybody. Take care. Bye.